Hello everyone, welcome to the Mechanical Studies. In this video, we will see detailed treatment of first law of thermodynamics applied to closed systems undergoing cycle as well as process. We will start here with energy balance, which is obtained from conservation of energy principle and which is written as E in minus E out. E in minus E out will be equal to delta E, where E in is total energy entering the system, E out is total energy leaving the system, and delta E is change in total energy of the system. Now remember here, left hand side of this energy balance, that is E in minus E out, represents net energy transfer by heat, work and mass, and which is given by net heat transfer, that is Q in minus Q out, plus net work transfer, that will be written as W in minus W out, plus net energy transfer by mass, so that will be written as EM in minus EM out, EM in minus EM out. Now as we are analyzing closed systems here, which we know do not permit transfer of mass across the boundary, this energy transfer by mass will not be considered here in analysis. On the another side, delta E represents change in total energy of a system, and that is given by change in internal energy plus change in kinetic energy plus change in potential energy. Change in potential energy. Now let's apply this energy balance to a closed system undergoing a cycle first. We know when system undergoes a cycle, it returns to its initial state such that initial and final conditions are identical. So here in this case, as the initial and final states are identical, change in any property of the system over entire cycle will be 0. Now here total energy of the system is also a property of system, and that's why we can write for entire cycle delta E equal to 0 as initial and final conditions are identical. So change in total energy over the entire cycle will be 0 here. Thus here energy balance can be written as E in minus E out. This will be equal to 0. Okay. So by considering energy transfer here, we can write in the next line as Q in minus Q out plus W in minus W out. This will be equal to 0, or we can write in the next line as Q in minus Q out. This will be equal to W out minus W in. Okay, and that is further written as Q net is equal to W net. Q net is equal to W net. Now remember here, very important point, this Q net represents net heat input provided to the system, and that is written as Q in minus Q out. That means heat supplied minus heat rejected. On the another side, this W net represents net work output delivered or produced by the system, which is actually W out minus W in. So that is a net work produced. That is work produced minus work consumed here. Okay. So the first law expressions applied to a closed system undergoing a cycle can be written in these various forms, where the first one is Q net is equal to W net. This is a generalized form. Second, we can write this as summation Q is equal to summation W. This form is particularly used when system undergoes multiple heat and work interactions. And the third one is cyclic integral of del Q is equal to cyclic integral of del W. This is a differential form of first law of thermodynamics. Now let's consider here a closed system undergoing a process in between initial and final states like this. So here this is initial state and this is the final state through which system proceeds. We can write now here energy balance as E in minus E out. This will be equal to delta E. Now considering here energy transfer by heat and work, we can write this as Q in minus Q out plus W in minus W out is equal to delta E. On the next line, we can write this as Q in minus Q out. This is net heat transfer minus, I can write this as W out minus W in. This will be equal to delta E, change in total energy of the system. And again I can write here as Q in minus Q out will be represented as Q net minus W out minus W in. This will be represented as W net is equal to delta E. So here again Q net represents net heat input provided to the system. W net represents net work delivered or produced by the system, and delta E change in total energy of the system. Now here closed systems are considered as stationary systems where change in kinetic energy and change in potential energy are neglected. So we can write here change in total energy delta E will be equal to change in internal energy delta U. And thus the final expressions of the first law of thermodynamics applied to a closed system undergoing a process can be written in these various forms. Most of the time this suffix net is not used and it is simply written as Q minus W is equal to delta U. So this is a generalized form of first law of thermodynamics. Second one you can see here, this is a differential form which is written as del Q minus del W is equal to du. So this is differential form of first law of thermodynamics applied to a closed system undergoing a process. Now please remember here in these expressions heat, work and internal energy are total quantities. That's why they are written in capital letters. However, the same expressions can be written on unit mass basis by using small letters like this. So here heat, work and internal energies are expressed on unit mass basis, and that's why they are expressed here with small letters. So please note here you can use these expressions for non-flow processes. That means the processes carried out in closed systems. Okay. In this way we have obtained final expressions of the first law of thermodynamics for closed system from energy balance. Thank you.